Hey everybody. How are you doing? Yeah? This is great. This is like just a group of friends. I like this. It's the way I want it. How many people, I'm Bruce Hauman. I wrote figwheel, which is a tool for ClojureScript. I'm going to talk about that more in a second. And I just want to get a feeling like for who's here, what they do. How many people work on the front end, JavaScript or ClojureScript or something like that? All right. How many people don't touch the front end? Wise people. Okay. That's cool. How many people use figwheel? All right. Cool. More than I expected. That's cool. I'm going to talk about literate interactive coding. And first, a little context. This is for the front end. This is for a single page application development. And I work in ClojureScript. And like a theme to the things I work on is I want to increase the feedback that I'm getting from my coding experience. I want to know how my code is behaving as quickly as possible, and I want to get as much information as possible about it. And my theory here is that when you increase this feedback, when you increase the data that you're getting about the behavior of your code, you start to enter this experience of flow. You kind of get the opportunity to surf this creativity and stop futzing with your tools, and stop waiting for things, and stop doing things that have no application to the code you're writing. So, tale of two tyrannies. People who work on the front end experience incessant browser reloading. And I think that's going to be an easier sell than the second one. This is the one I'm most worried about selling, and that is developing inside the main application, having that be your main avenue of feedback, is also an unpleasant experience. And another theme of my talk is I want pragmatic solutions. I want solutions that I can use today. I don't want to have to wait for some other person to solve this with buckets of code. I want to leverage, I want small levers that I can pull that are simple with a finite amount of code to get me back into this situation where I'm getting this feedback, that helps me stay in a state of flow. Which I think, basically what I'm saying is I just want to have fun when I program. I don't want this experience of constant interruption and constant worrying about what my tools are doing. Okay, and so there's a problem, and the problem is that this slide is blank. Okay. All right. And it is blank. So I happen to have written this slideshow in ClojureScript, my language of choice. And I'm going to edit my ClojureScript. That was a comment. I'm uncommenting the next line of my slide. All right. I'm going to save my file. Okay. And then I'm going to do what every JavaScript developer does a lot of the time. I'm going to reload the browser. Then I'm going to go back to the state I was in. I'm going to go back to the slide. Okay? And we're getting there. Okay. So what was the problem? So the problem is we have this code reload, right? We write a little code. We reload the browser. We manipulate our program, back into the state we were just in so that we can verify the behavior of our code. And wait, I got to uncomment the next line here. Hold on. All right, I save my file. I'm going to reload the browser. Okay, it's already here. Let's get back. What is that next line? Okay, and the reason this is a problem is because UI coding is basically endless tweaking. There's just a high number of iterations. You're always adjusting this. You're always checking this behavior. And it just, because you're doing this so many times, this interruption of reloading the browser and then getting back into the state that you were in is no fun. And it costs. The cost in time is there, but there's also a cost in flow. There's also, you wrote some code, you have a question. Does this code work? And then you wait a couple seconds to find out. It's kind of dead time. There's not time there to kind of think about another problem. It's kind of dead time, and it accumulates, and it can lead to a kind of a numbness, especially if you're constantly like filling out a form or something like that. Like, mechanical actions do not inspire creativity. You can quote me on that. I mean, all right. So did I make the point, or do I have to keep doing this? All right. Okay, great. All right, so let me, I'm not going to make you do that again. So let me turn on hot code reloading. Okay, and this is figwheel. This is the tool I wrote for Java, for ClojureScript. And I'm going to uncomment this next line. So there's a solution to this problem, right? And that solution is hot code reloading. Did you notice a difference in the experience? It's a completely different experience. In fact, I can walk down here. And like I mentioned, I want pragmatic solutions, right? People are working on this problem of being able to reload. And there are interesting solutions like declarative programming. You can reload that. Database programming, you can reload these things. But we work in the land of JavaScript and Java. We work in this imperative world where we have problems that need some imperative solutions. So I do not want to solve the problem, and I don't want to wait for this problem to be solved. I want to be able to write reloadable code now. I want to be able to experience hot reloading now because of the inherent situation of endless tweaking. I just want it now. So my solution is just write code that is reloadable. We're all programmers. We can think about the load time side effects of our code. And it's really understandable. It's really understandable to think about, well, maybe this section of code shouldn't be run every single time the file loads. So you protect it. All right? And something happened in the JavaScript landscape. React.js came along, and ClojureScript, React.js allows you to declaratively program against the DOM, against this stateful enemy of ours. And ClojureScript gives us sane semantics around programming. And because ClojureScript has a great incremental compilation story, you get this effect, right, of having, instantaneous experience of changing your code and then seeing how it's actually behaving. All right? So figwheel, help me out here. People who use figwheel, do you like it? All right? Did it change the experience of your day-to-day coding? All right? So people seem to love it. And the trade-off of having to write reloadable code seems to be like there's a high return on investment for writing some reloadable code and being able to see your changes instantly. And it turns out that reloadable code prevents you from doing some really, I don't want to say idiotic. Yeah, idiotic thing. It prevents you from doing things that just are not good. All right, so that's all the time I have for figwheel and talking about code reloading, because that's not what this talk is about. All right, what is this talk about? Okay. Oh, and another thing is that you can't judge this experience. I've said this before. You can't judge the experience of writing code and getting instant feedback from hot reloading until you do it. You know, you can't say, oh yeah, I could just reload the browser. I mean, until you experience it, you can't really judge it. All right, so the next problem is much more difficult for me to describe, and I've worked on it. So here goes. Once you start working and doing hot reloading and seeing the behavior of your application change instantly, once you start doing that, you start to notice that there are other constrictions. You start to notice that I'm still doing a lot of mechanical stuff. And I don't feel like I can just, did I unplug myself? I can project. I unplugged myself. Are you sure? Do you want me to give this to you?
Yes, I'll take that.
All right.
I think you killed the battery switch too.
Is it my voice?
No. Just keep talking, I'll fix it. No, come back up.
Don't mind my assistant. What's experiential, blah, 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 blah. Okay, so you start to notice there are other constrictions. And because we've been developing in a certain way for a very long period of time, we always write our code and we see it in the main application. We always see its behavior in the main application. This is where, how are we doing? Okay. And now, so you have these avenues of information come to you about your code. Whoa. Whoa, okay. Am I going to burn this one out too?
No,
or?
I'm going to turn you down.
Okay. All right, are we already at a decent level now? Okay, good. What was I talking about? Again, this is the hard part of the explanation. So it's good to have little interruptions. Okay, so you have this avenue of information. You write your code and you see it behaving in the main application, right? You have a to-dos application, and you've got the form field, and you've got the list of to-dos, and you write your code, and then you see how the to-dos are behaving. And now you may also have a test suite, okay? But that's normally not for visual code, right? You know, you have this test suite running to give you feedback on how the changes you're making to your data transitions and whatnot. So you have this other avenue of code, of feedback, but I'm going to forget about that right now. So if the main application is the window into your code, think about our behavior against the main application. Think about what we're doing. So you write your code, and now it's time to check it in the main application. And so normally our behavior is we check this state. All right, and then, okay, well, I should probably check this state too. Oh, and I'm gonna check this state, and no, how about this state and this state? And so we're doing this thing, we're checking state after state. We're manipulating the program into a bunch of different states, and it's really informal. It's just like, hey, did that work? Yeah, it looks like it did. And your application, so the point is your application can only have one state at a time, and you're interacting with it serially. You're testing one state after another. And so it kind of begs the question, wouldn't it be great to see your application and or its components in several states at the same time? Wouldn't it be great to see your to-do item in several different states, including erroneous states, empty states, overflow states, all at the same time? And then while you're developing, you get to see the behavior in parallel. All right? You get to, so you're increasing the feedback and you're reducing the amount of manipulation you have to do in the browser. All right? And so It's time for a demo. So right now I'm using Devcards. Okay, Devcards is a tool that I wrote for ClojureScript. Am I still on? Okay, I heard this thing. It was probably just my head. So it's this tool that I wrote for ClojureScript that lets you have, and I'm going to quote David Nolan here, a visual namespaces. You get to have namespaces, and you get to have visual aspects of these namespaces. And so in each of these namespaces, there are code examples that I can navigate into. So I'm just going to go into the to-dos namespace here. And in this namespace, let me switch. You guys cannot read that probably. Tell me when, guys. Does that work? More. Sorry. How about that? Good? All right. All right, so Devcards is an attempt to create a lab space. A place that you can work inside of and have a lot of latitude. You do not have to find a place in the main application to try code out. All right? And so Devcards operates, it's just a ClojureScript library, and it operates around the idea of this single macro called Devcard. All right? And when you pass, in this case, I'm passing Devcard a string. It's a string of markdown, right? And it's getting loaded in to the strange loop to-dos namespace, which happens to be the namespace that we're in. Okay? And they're designed to work interactively. So if I uncomment this next one, I'm taking this literate markdown out of my source file, and I'm raising it into the Devcards interface. All right? Now, interactively rendering Markdown might not seem interesting, but it allows you to start creating documents with textual content. All right, so now I have a square range here. Actually, let me just change that. I'm going to introduce a bug. So Devcards, I'm going to render this card into my interface, right? So it'll render closure values, all right? And it can have an identifier. All right, can you guys see my mouse? All right, so you can have an identifier, which is really helpful because you want to be able to map the code that's in your source file, the code example, to a card that is in the Devcards interface. And these appear in order. Now this square range is written incorrectly. I broke it a second ago. And let's make it a square range. Okay, and so again, it changes immediately. So this is different than a REPL, right? Because this is more of a spy that's constantly looking at my code. I can create as many code examples as I want. And as I change my code, all the code examples are updating with a value. Now, Devcards was not created to work against value. Work against like closure values. It's helpful. It's helpful for you to look at, what's in an atom. It's helpful. But really what it was made to work with is React. All right? So here, I'm creating a React element, which is so this is the Lispy hiccups. Is everybody comfortable with this idea of expressing the DOM? Everybody okay with that? Okay, it's a Lispy expression of the DOM. And I can jam with it. Like, I can just work on some DOM without even having, I'm not even sure what I'm doing yet, but I'm just creating some DOM and I'm throwing it up there, and I can interactively work with it until I get a shape that I like, and then I can extract it into a function, and then I can create a template out of it or a component. But again, like I'm freed myself from the environment of the main application, and I can pretty much do as I please to help me work on my problem. Okay. Now, does anybody have like any quick questions about what's going on here? Is anybody like, what?
What happens with style and things like that are obviously not going to be applied here?
You can write CSS against this as well. Does that make sense? Like this does have style applied to it, intended for the application. Does that make sense? Yeah. Okay. And I've tried to be careful with how Devcards handles CSS, but it's CSS. You know, it's CSS. But I tried to be careful. So you can also get rid of cards, right? So this is it's a lab space. You're like, okay, I don't need that card. I don't need that card for now. I don't need this card. So I'm just commenting them out. All right? And so let's work on a to-do item. All right? So I'm raising up some markdown, and I'm actually demonstrating like the shape of my data here. Right? I've got some to-dos. They have IDs, they have content, and they have an optional completed Boolean on there. So I'm just raising that up for my information, maybe another developer's future information, so they can come here and they can be like, okay, that's what the data looks like. Okay, and I have this to-do item that's like a lot of functionality has been commented out so that I can simulate live programming because there is no way that I'm going to do it. All right? And now, so here's what I call example-driven development, right? So I want to see what a to-do item looks like. So right here we have a singular to-do item rendered. It's our first to-do item, right? And I'm rendering the first to-do item right here. So here's a code example, and I can add a little commentary about how it should be behaving. All right? Now, instead of working on the to-do item, I'm going to create a couple more examples. Like, what does a completed to-do item look like? All right? And so there's another one. That's wash the car, and we happen to know up here that wash the car has been completed. Now, we notice that it's not actually evident that it's completed here, so that functionality hasn't been implemented. All right? But let's look at something a little more. Let's look at a borderline case, right? Of blank to-dos, right? And this is where, the number of states that even a to-do item has, right? We're talking about a to-do, item. It's got very little data associated with the number of states that it can embody, especially in combination with other to-do items, becomes very, very large. And we normally do not check this stuff, especially like programs evolve, and we don't have a lot of good ways of checking this stuff. So what I did is I put some blank to-do items in there. We can see they're just rendering as empty cells, which is ugly. But what if we just add a couple? Let's add some content in there too. Okay, so now we have this situation where we can test like how do blank to-do items render, mixed in with other to-do items in different states. That's again, this is a combinatorial explosion of possibilities, and we don't even check any of them these days. Not really. We just say, oh, that doesn't look right anymore. Oh. So again, more feedback that I can get from my code if I set up these examples. And let's look at long to-dos. All right? I can see how they're rendering. And now I can go back and I can be like, I'm going to start working on to-dos. First, I'm going to get this completed to-do rendering correctly by adding a completed CSS style. And you see that the wash the car is now completed. And you can see that it's completed here in this example. All right? And actually, I forgot one example. It's just the list. And in this example, too, where I'm just listing all the to-dos. So I can see it's completed in these different states. All right? And now let's look at the blank to-do item. I'm going to edit. I'm going to say, if a to-do is blank, just don't render it. Okay? And you can see here I have some comments. So if somebody, like, you can imagine handing a document off to the QA and that has these are the components in different states, and I'd really like you to verify, like read the comments and, and see that they're behaving the way they're intended to. Like, add some eyes to this problem of verifying instead of having people walk through every state, in the main application, somewhat, random walk. All right, okay, so I think that's my spiel for multiple. So does this make sense? Does this make sense? Come on, I want a little affirmation here. All right. Does anybody find it odd that we're not doing this? I mean, I don't know. Is it just me? So, it is just me. We are doing this? Okay, work for that company. All right. So now let's talk about now that we have this space where we can, we have a lot more latitude, and because we're using React elements, literally you can make anything with a React element, right? So you can make a React component, any kind of tooling you want, right? You could just make it, put it in a function, and then whatever parameterization you want to give it, you can start making tools to help yourself. And now there's a place to put it, right? There's a place you can put it into. So I happen to know that there's a bug. Actually, there isn't a bug. There should be a bug. That looks like a bug. Okay, so I want to start working on my state transition functions. And normally I check this in the REPL or whatnot, but let's see. I'm completing the first of my sample to-dos. And that should put a completed true, right? This is just returning Eden. It's returning ClojureScript data. And this should be marked true. It's not working, all right? Well, that's cool. I can inspect data. But what about tests, right? Like, I redefined the def test macro. It is completely compatible with CLJS test. And now I can raise my tests. So I'm taking the opportunity that I have of having a lab space, and I created a very thin tool, right? Because I'm a UI programmer, I have the expertise. I created a thin tool to help me understand my code, all right? And it's live, so as I update, right? As I update my code, I can see completed is true, and all my tests are passing. All right? And I'm going to underline this one more time. Like, really, you can create tools. So I'm going to work on adding a state transition to this buy bread, to this to-do item. And Devcards, it dispatches on value. And if I pass it a function, right? If I pass it a function, it's handed a ClojureScript state atom. And you can initialize this state atom with initial value, all right? And that's one way of doing this. I'm still thinking about ways to handle this, but it's nice to have like a state that's associated with an independent code example, right? I'm emphasizing independent code examples here. And so people can put whatever they want in this atom, then take it out and apply their components. But also, like, I'm a UI programmer, so I added, hey, now that I know what the state is, I can inspect it. And because they're persistent data structures in ClojureScript, I can record the history. And this is not very, this is a thin amount of code here. But I'm able to leverage the environment that I know so well to create tools to let me see the behavior of my code. And so I'm going to go back up here to the to-do item, and I'm going to add a done button, which happens to be added everywhere else. And I can see that it's behaving correctly, right? The completed to-dos don't have a done button, all right? And let's see if it's working. All right. Now, you notice this. Did you guys hear anything? Okay. So did you notice this back button here, right? This back button, I can go back in time and try it again. Now, if you do accomplish something in this world, you should get rewarded, right? And it shouldn't just be the same thing every time. So let's add let's add undo as well. All right, so now I can undo. I can do. That was a longer reward. I think it's because I'm farther into the talk. Okay, so yeah, I can, and let's do it again. Why not, right? So now I can walk back through these states, right? I can just. Does anybody think this would be helpful while you're developing independent components to be able to see the state and walk forward and walk backward through it? And again, this is not like, I'm not writing buckets of code here. This is a very thin wrapper, all right? But since I happen to be a UI programmer, I can take advantage of this and have tools. Like, I don't want to wait for some mega IDE developer to be like, I've figured out how you should code. I mean, I know my problem domain. I know what I'm working on. I can make tools for myself. Did I hammer that point home? I think I've said it. I said it, yeah, I did say it a few times. All right, so, but also, there's a place, again, like, so I wrote a music generator, but I wanted some insight into the function that was generating the music, right? So just throw a graph up there, get a little insight into, let me go to the music. All right. It doesn't matter if you can see this. So I, as I was working, on this music generator, it's nice to get this feedback and see what's happening. And also, let's see what it sounds like with a different voice. This is all web audio, by the way. And I'm going to try a piano. That sounds better. Maybe I'll use that. So, I think we are getting towards the conclusion of this talk. It went much faster than I expected. Let's go back here. Okay, so I'm going to repeat everything I just said. Okay. Now, one thing I didn't say, right, is when you develop code outside of the main application, no, if you develop code inside of the main application, it's really hard to see environmental coupling, right? Remember back your unit testing, right? You're like, okay, now I'm going to test this, and you're like, my setup my setup is like 40 lines of code, or 100 lines of code, and it's putting stuff in the database, and you're like, there's environmental coupling. There's a lot of it. But when you test first, you tend to not want to have to write 20 lines of setup or 100 lines of setup, and so it reduces environmental coupling. When you develop code outside of the main application, the environment of the main, you just tend to make things more independent. Flexibility to express yourself and do whatever you want. Like in the middle of the day, you just want to write a tic-tac-toe. Easter egg, you just do it. Doesn't matter. A validation document, right? You can create documents that are live, that people can interact with and see the behavior of your individual components, and that those have value, right? Because these, I didn't say it, but these code examples can persist as long as you want them to. They're no longer this ephemeral thing that happens while you're coding. They're becoming manifest. And a reference document, which, like a kitchen sink or a CSS style guide, like this reference document so other programmers can see how this code is supposed to be exercised. All right. So, I'm still working on the tagline. This is my current one. Hot reloading increases the rate of feedback, right? You're getting instant feedback. But developing outside the main application can increase the bandwidth of feedback, which again can keep you in a state of flow and you can have a lot more fun. Yeah. Whew. Did I breathe during that? Did I? Okay. Questions? I feel like I skipped something. Anyway, questions?
I do regular Clojure development.
It is tied to ClojureScript, but if you really want to develop in CLJC and then bring it back into the Clojure world, you are welcome to. Does that make sense? The question was, he wants to do this in Clojure, but this is for ClojureScript. I really think more people should do that. No, I'm kidding.
But doesn't it depend on React?
What? Yes. Oh, yeah. For visual development, it depends on React, but for algorithmic and database development, right? You don't have to have React. All right. Any more questions? Yes. Yes, sir. You guys, that's the team that said we're already doing this. All right. Yes, sir.
So this seems like it would be really nice to have the test code within like entirely independently of ClojureScript. So how easy would this be to use as a front end?
How to test code that isn't ClojureScript, but like.
Like if I have like a functional code base and I want to use this as a UI to like test a whole bunch of functions at once, how hard is that?
The question is, how it's similar to the other questions. How hard would it be to adapt Devcards or something like it to, say, like F# or Clojure or it's kind of a different problem because this really is for people who are working in the browser, but you could make something like this. I don't see why not. Yes.
What I meant was, could I use this and my web browser as a front end to like debug, say, okay, I'm going to or F# code or something that I could like load one function at a time and then display.
You mean Devcards in particular? Can you use Devcards in particular to do this? I don't think so. It hasn't been abstracted in a way to do that. Like, I think, yeah, people have asked about doing this with Clojure, but I haven't put any effort into doing that at all. Yes, sir?
Have you experimented with getting even very simple user interface around choosing color styles, for example? Something similar where we can choose very simple drop values for components, and for development, it's actually pretty cool. Have you tried something like this?
So I don't know if I completely heard you very well, but are you saying that it'd be nice to have tools that let you change the states of your components in the browser? Is that correct? Yeah. So like again, that's a very easy thing to write. It's really easy to write tooling like that. Like like a form to change props and maybe even introspect, but I don't know if that's possible. But you could write tooling for like that and easily use it with a system like this because again, it just renders a React component, and so I think it's important that it stay general so that you can create whatever tools you want, and that would be like that could be an extra library that you pull in of like the Anything else? So in general, like, what do people, like, you have to know that I've been working on this on my own. The feedback, I don't get a lot of feedback. Some people, like, what do people think in general?
I'm rewriting applications in my head right now.
Okay, good. That's all I need to hear. That's all I need. I'm done, right? Okay. Hey, thank you very much, everybody.